Hello friends, welcome to today's lecture Flexibility Method. Myself Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yadrao. So in the last lecture we discussed about flexibility method and how to apply this method to analyze of the structure. So in this method, the basic thing or the main thing is to develop the flexibility matrix. So let us see in this lecture about how to develop flexibility matrix. Develop a flexibility matrix for the beam AB with the reference to the coordinate shown in figure. So this is the cantilever beam AB. At A is a fixed end and at B is a free end. And on that AB there are four coordinates, means 2 point load and 2 moments. So first is a moment at point C at a distance of 10 meter from point A. Then second one is a point load at C, vertical downward. Then third coordinate is moment at B, means at B at a distance of 20 meter from end A. And fourth is a point load at B. So this is the M diagram. Now I convert this M diagram into different diagrams. That is, suppose remove all forces, just take one moment at C, that is coordinate number 1. This is called as M1 diagram. Then next, remove all coordinates, just take point load at C, that is 1 kilonewton or 1 kilonewton meter. So these coordinates are unit coordinates, means that moment is equal to 1 kilonewton per 1 kilonewton meter, or force is 1 kilonewton. So whatever the intensity of the moment or force is 1. Then this is called as M2 diagram. Then next, consider remove all forces, just take coordinate number 3, that is moment at free end. And last one, just take unit load at 1, unit load at free end, that is 1. That's called M1, M2, M3 and M4 diagram. So prepare one table. In that table mark columns, that is first is a portion, second one is origin, third is limit, then M1, M2, M3 and M4. So first portion is B to C, means our consideration is B to C. So portion is B to C. Consider origin B. So between B to C, or that C to B, distance is 10 meter. So from point B to C, that limits will be 0 to 10. Means if you starting from point B, it start with 0 and end with C, it's end with 10. For the BC portion, now we calculate moments due to this all four coordinates separately. First of all, I want to taking moment about B. Whatever the moment for this BC portion I consider with respect to B. So M1 means that moment due to coordinate 1. So this is the BC portion. I am just considering BC, means there is no load in between B to C. So that M1 becomes 0. Similar way, now I consider second coordinate, that is point load at point C, taking moment about B. I am just considering now this is the BC portion. So this is in between B to C, there is no load. So M2 becomes 0. Now I am considering coordinate number 3, that is in M3 diagram. So this is the M3 with respect to B. Now this is a one moment, that is clockwise moment, and clockwise moment on the right side is -1, that is M3 is -1, and this is the moment. So moment is directly considered without multiplying distance. Now at coordinate number 4, that is point load at free end at point B. Now I taking moment. So this is variable, that is B to C, means that limits is up to B to C. Suppose load at point B, there is no moment. If the load moves towards C at a distance of X, so suppose this is a X. So moment is 1 into X, and the direction of the moment is anti-clockwise. Left side anti-clockwise is minus. So 1 into X, that is X, and direction of the moment is anti-clockwise, so minus X. Means when consider portion BC and origin B, that M1 is 0, M2 becomes 0, M3 is minus 1, and M4 is minus X. Next, now consider portion C to A. Now CA, once again consider origin B. Okay. Now consider CA portion, origin B. Now limits become, I am considering only AC portion. So limits become 10 to 20. From point B, C point is a 10 meter point, and from point B, A point is a 20 meter point. So limits becomes 10 to 20. Now due to coordinate 1, that is first M1 diagram. This is directly moment. So moment is unit moment. That consider minus 1 with respect to B. Then next M2 diagram. That M2 diagram consists a point load at point C. With respect to B, what is the moment due to this 1 kilonewton force? That is 1 into, suppose this is the 10, and this load moves from C to A, and this distance is X, and suppose this is load acting at distance of X from point C. So it becomes, this is the X minus whatever the CB distance is 10, and direction of the moment is anti-clockwise. So minus 1 into X minus 10, and that X measures from point B. This is for M2 diagram. Then next consider third coordinate, that is a moment at the point B. So directly consider plus or minus. Direction of the moment is clockwise, consider right side is minus 1. Then next at distance or at coordinate number 4, that is point load at point B. So from B, X measures from point B. So this is directly 1 into, suppose this is the load moving towards A. So it becomes directly similar as that point load, that is X 1 into X, and the direction of the moment is anti-clockwise, right side and the left side anti-clockwise, that is minus 1 into X. So it becomes X. So this is form a table. This table is useful to find out flexibility matrix. So flexibility coefficient by unit load method. Now we know the table, that is M1, M2, M3 and M4 value, and with their limits. So for flexibility matrix, that coordinates are 4. So flexibility matrix size is 4 by 4, that is 4 rows and 4 columns. So starts with F11. F11 means if I want to find out coordinate at F11, I want to take integration of M1 into M1 with respect to dx upon EI. So integration of M1 into M1 dx upon EI, and we know the limits for M1 is 10 to 20. 10 to 20. So M1 is minus 1. M1 also is minus 1 into minus 1 dx upon EI. By simplifying this equation, we got 10 upon EI. This is the value of F11 coordinate. Then I want to take second coordinate, that is F12, and in flexibility matrix the coordinates are same for F12 and F21. So that F12 and F21 are coordinates same. How to calculate that F1 and F21, F12 and F21? That is integration of M1 into M2 dx upon EI. Okay, so M1 becomes minus 1 and m2 becomes x into x minus 10 with respect to, that is limits are 10 to 20 dx upon ei. By simplifying this equation, that is x, integration of x is x square by 2 and integration of 10 is minus x, and limits are 10 to 20, 1 upon ei. Ei is a constant, so that answer becomes 50 upon ei. The coordinates for f12 and f21 becomes 50 upon ei. So simply this is multiplying. If I want to calculate f12, just you multiply m1 into m2. If I want to calculate f11, you just multiply m1 into m1 dx upon ei. Similar way, I want to calculate f22. So f22 becomes integration of m2 into m2 dx upon ei. So take the integration with limits 10 to 20, m2 becomes x minus 10 into x minus 10 dx upon ei. Integration 10 to 20, x minus 10 becomes x square minus 20x plus 100 dx upon ei. Take integration with respect to x, the equation becomes x cube by 3 minus 20x square by 2 plus 100x with limits 10 to 20, 1 upon ei. So simplifying this equation, put up upper limit and lower limit, we got f22 value is 333.33 upon ei. So this is the f22 coordinate. Next, find out f13 and f31, that both coordinates are same, that is f13 and f31 is same. So suppose I want to find out f13, then I want to multiply m1 into m3, integration of m1 into m3 with respect to dx upon ei. So integration limits is, upper limit is 20, lower limit is 10, and m1 is minus 1, m3 is minus 1. Minus 1 into minus 1 into dx upon ei. So that f13 and f31 is equal to 10 upon ei. Then similar way, calculate f23 and f32, and both values are same, that is f23 is equal to f32. Means I want to multiply for this coordinate, that is m2 into m3 with respect to dx upon ei. So limits become 10 to 20, that m2 value is minus 1 into x minus 10 and m3 is minus 1 dx upon ei. So simplifying this equation, integration of 10 to 20, that is x minus 10 dx upon ei. By solving this equation, we got f23 is equal to f32 is equal to 50 upon ei. Then f33, that f33 means integration of m3 into m3 dx upon ei. So m3 is 1, 0 to 10 into 1 minus 1 into minus 1, that is plus 1 dx upon ei, plus second, that is this is for first BC portion. Now that AC is 10 to 20, that limits are changed, that is 1 into dx upon ei. For this is the first, this BC portion, and this is the AC portion, that m3 value are different for BC and AC portion. That's why we consider separately, due to that limits are different. So that solving this equation, we got f33 becomes 20 upon ei. Then next, f14 is equal to f41. So it becomes integration of m1 into m4 into dx upon ei. With the limits of 10 to 20, m1 and m4 becomes x dx upon ei. By solving this equation, f41 is equal to f14 is equal to 150 upon ei. Then next, f24 is equal to f42. So it becomes m2 into m4 dx upon ei. Take the integration with upper limits is 20, lower limit is 10, that is x minus x in bracket x minus 10 into dx upon ei. By solving this equation, we got m24 is equal to f24 is equal to 833.33 ei. Next, F34 is equal to F43 is equal to take the integration of M3 into M4 dx upon EI. Put the M3 value with limits 0 to 10, that is x dx upon EI, plus integration of 10 to 20 limits x dx upon EI. So by solving this equation we got M34 is equal to F43 is equal to 200 upon EI. Then next, F44. So F44 is equal to integration of M4 into M4 dx upon EI is equal to, limits is, upper limit is 10, lower limit is 0, x square dx upon EI, plus 10 lower limit, upper limit is 20, x square dx upon EI. So solving this equation we got F44 is equal to 2666.7 upon EI. See here, if in previous table that M4 value are both condition, that is in for portion BC and portion CA. That's why you consider these two limits, that is first for that M4 into M4 for portion BC, then M4 into M4 for portion AC. That's why limits are changed. First limit is 0 to 10, second limit is 10 to 20. This is the F44. Now we know the all values, that is F11, F12, F13, F14, similar way up to F41, F42, F43, F44. Put up all values in this equation. So 1 upon EI is a constant term, so take outside of the bracket, and that F11 is 10, F12 is 50. See here, F12 is 50, so F21 becomes 50. F13 is 10, F31 is 10. F14 is 150, F41 is a 150. In this manner, plot all values in this equation, and this is called as flexibility matrix. So this flexibility matrix is useful for solving problem by using flexibility method. Thank you.